Welcome to a video on solving absolute value equations. For this example, we have multiple parts. Let's begin with letter A. The absolute value of y minus 4 is equal to 7, which means that the expression y minus 4 is 7 units from 0. So we can start out with a sketch to interpret the meaning of an absolute value statement. The expression inside the absolute value is 7 units from the origin. So on the number line, 7 units from 0 means that the expression is either -7 or the expression y minus 4 is +7. These 2 points are precisely 7 units from 0. And so we would take the expression inside the absolute value, set it equal to those numerical values on the number line, which gives us these two statements. This should have been a +7 there. So solving for the first equation, we're going to add 4 to both sides, making a y value of -3. And for the second one, we're going to add 4 as well, making y a value of 11. So the solution set, we can put it in either set notation, which consists of the squiggly brackets, or we call them braces, and then write the solutions in the set. On problem B, we're going to first start by isolating the absolute value term, so subtracting the 2 to both sides so that we can start interpreting the absolute value statement. This gives us 12 is equal to the absolute value of 4 minus 2/7 of x. And now we're going to interpret this. Again, draw a number line, label the origin. Absolute value means distance. So this expression here is 12 units from 0. 12 units from 0 are either -12 or +12 on the number line. So the absolute value expression, which is 4 minus 2/7 of x, is either -12 or is equal to +12. And now we have two linear equations, which means that we can solve for x. Now at this point, we can get rid of the constant and then divide by the linear coefficient. Or if you're like me, which I do not like fractions, so I'm going to get rid of fractions from the very beginning. To do that, we're going to multiply the first equation there by the LCD, which is the least common denominator of the statement. And I'm going to do the same for the second equation there as well. Distributing the 7 through, I get 28 minus now 7 divides out, so we get 2x, and then 7 times -12 is -84. For the second equation, do the same. Distribute the 7 through, so we get 28 minus 2x. The 7 here divides out with the LCD, and then equals +84 this time, and then equals 84. Now our equation looks a little bit simpler to solve. So from here, subtract 28 to both sides. We get -2x equals -112. And now divide both sides by -2, which gives us 56. Negative over negative is positive, so one of the solutions is +56. For the second equation there, do the same. So subtract 28 to both sides. We get -2x is equal to, subtracting 28 now to the other side, we get a 6 here, 7 minus 2, so that's 5. So 56 as a result. And now divide by -2. So half of -56 is 28 negative. So we have two solutions, and in solution set form, that would be 56 and negative 28. Let's move on to the other two parts. On letter C, similar to part B, we want to start with isolating the absolute value term. So in other words, we're going to get rid of the 7 there and the coefficient 3. To get rid of a negative 7, we're going to add 7 to both sides. This simplifies into 3 times the absolute value of 2x plus 3 is now 6. Our next step then is to divide everything by 3. Hence, it becomes absolute value of 2x plus 3 is equal to 2. So again, I'm going to sketch out a number line to interpret this. Mark 0. And then we want 2x plus 3 to be precisely 2 units from 0. So 2 units from 0, distance of 2 units from 0 is at either negative 2 or positive 2. So 2x plus 3 equals negative 2, or 2x plus 3 equals positive 2. Solving for x, subtract 3 to both sides, making the other side a negative 5. Divide by 2, so negative 5 halves is one of the two solutions. And now 2x equals negative 1 by subtracting 3 to both sides on the second equation. Divide by 2, hence x is equal to negative 1/2. So we have two solutions to part C of the problem. For part D, similar to the other ones, so again, start out with isolating the absolute value term. In other words, get rid of the constant term, subtract it to both sides. Now we're left with the absolute value of 2x minus 5 is equal to 0. And now to interpret this absolute value statement, 2x minus 5 is 0 unit from 0. So 0 unit from 0 is precisely at the origin. There's only 1 point. That means 2x minus 5 is 0. And now solve the equation for x. Add 5 to both sides and then divide by 2. So this one only has one solution, and that is 5 halves. Part E, to solve this absolute value statement, notice that we have absolute value on both sides. So that basically ensures that either side is non-negative. Non-negative means that either expression is a value of 0 or positive. So we can treat this as a non-negative number, which means that we are given at least one solution to the value of m. Think of the right-hand side of the equation as a positive constant. We're going to interpret the absolute value equation using the absolute value of 5m plus 7 as the absolute value term. So 5m plus 7 is either equal to the positive of this value, which is 4m plus 3, or 5m plus 7 is equal to the negative of the expression 4m plus 3. So to indicate that, we're going to apply the negative to that quantity. So imagine if this expression here represents a non-negative number, say, I don't know, maybe 15. So if this is equal to 15 on the number line, 5m plus 7 is positive 15, or 5m plus 7 is the opposite of 15. So as you can see there, 15 is just a numerical example to set up the equations to solve this absolute value statement. Now we're going to solve for m by combining like terms first. So subtract 4m to both sides, resulting in only 1m on the left, and then subtract 7 to both sides, making the right-hand side a value of negative 4. And now on the second statement, let's go ahead and distribute the negative through. So that makes it negative 4m minus 3 on the right side. And then combining like terms, add 4m to both sides, making the left-hand side 9m. And now subtract 7 to both sides, making the right-hand side a constant of negative 10. And now divide everything by 9. So for this statement, we have two solutions, negative 4 and negative 10/9. So on letter F, solve this absolute value statement. Let's start with subtracting 2 to both sides, leaving us with a negative absolute value of x minus 5 is positive 2 now. Divide everything by a negative. So remember not to distribute the negative sign to the absolute value expression because absolute value is not a set of parentheses. Think of this as the absolute value of x minus 5 times a negative 1. And therefore, to get rid of this negative, we can divide everything by negative 1. And that will isolate the absolute value term for us. 2 divided by negative 1 is negative 2. Now, if we were to interpret this statement, this means x minus 5 is negative 2 units from the origin. There's no point on the number line to be negative 2 units from 0. Distance can never be negative, in other words, and therefore the result of an absolute value can never be negative, and hence the statement has no solution.